Okay, this is your 4.1 video. The notes for this are due in class on Friday. Chapter 4 is all about triangles, and so the first section is really basic, trying to review you about what a triangle is and all the types of triangles and that kind of stuff. So most of it is vocabulary, and most of it you should already know, but it is worth a good review. Okay, so first of all, a triangle, you know a triangle is a polygon with 3 sides. So closed figure, 3 straight sides. Then we can start to classify what kind of triangle it is from there. And there are 2 ways to classify a triangle: by its angle measures or by its side lengths. So while we start out here, I'll tell you one or the other, but in the future I'll want both. So you'll say an obtuse scalene triangle, an equilateral, equiangular triangle, that kind of stuff. So we'll want to use both of them. Okay, so first we want to classify this triangle by its angle measures. So set A says angle or triangle ABD. This is the symbol for triangle, so you don't have to write the word, just like the symbol for angle and that kind of stuff. So triangle ABD. So let's look here. This is 20 degrees, this angle here. This angle is 80. This is hard to read, but this is the angle that's 100. So if this angle is 100 on this side, then how much is this angle on this side? Okay, that would also be 80 degrees because there are 180 degrees, or because these are a linear pair right there, so that's going to be 80. So if you want to kind of blow that up a little bit, this would be 80, 80, and 20. Okay, so I forgot to go over these. Your choices for classifying by angles are acute, with all 3 acute, equiangular, if they're all 3 congruent acute angles, and if they're all 3 congruent, and you already know from previous years that you have 180 degrees in a triangle, which means that these are all 60, 60, 60. And that's the only thing that an equiangular triangle can be. You can't have one that's 50, 50, 50. It's got to be 60, 60, 60. Okay, a right triangle has 1 right angle, and an obtuse triangle has 1 obtuse angle. So here we have 80, 80, 80. These are all 3 acute angles, so this is an acute triangle. Okay, y'all try the second one by yourself. Okay, so triangle BCD is here, so that's 10, that's 100, so that would be 70 over here on this side. So since 100 degrees is obtuse, then this is an obtuse triangle. Okay, I didn't ask you to, but if you also did triangle ADC, you would say that is a right triangle because angle D is a right angle. So there you've seen almost every kind right there. Okay, now let's go over and classify by side lengths. You have 3 choices for side lengths. Equilateral, if they're all 3 congruent. Isosceles, now here's one that they kind of gloss over in earlier years. The true definition for isosceles is at least 2 congruent sides. So you know that this is isosceles because it has 2 congruent sides. But the true definition says at least 2. So technically, every equilateral triangle is also isosceles because it has at least 2 congruent sides. We just like to be more specific and call this equilateral where this is just plain old isosceles. But technically, this is isosceles and equilateral. So just be careful with that. That might come up later. Okay, so we're going to classify by side lengths here. So first, triangle EFH. So we can see that this is 12. This is 10, and these are marked congruent, so this is also 10. So since it has 2 congruent sides, I would call this an isosceles triangle. I wonder if I could spell isosceles, that would help. How about that? Isosceles triangle. Okay, y'all try the other one. The other 2, actually. Okay, so FHG is 10, 4, 11, so none of the sides are the same, so that is scalene. And EHG, that is 12, 10, and 14, so none of those sides are the same, so that is also scalene. Okay, example 3. Find the side lengths of triangle JKL. So we can see right away that this is an isosceles triangle because of the tick marks. So if I need to find out how much x is, then I just need to set these two isosceles sides the same. We did a lot of this in chapter 1 when we were finding side lengths and line segments and things of that nature. So same kind of concept here. So now we have an algebra expression, so we can just solve. Okay, so we have 2x is equal to 17. So x is equal to 17 halves. Okay, now the question doesn't say what is x equal, it says what are the side lengths equal. So I need to go back and plug all of this in. So let's do the other side because it looks easier. 2 times 17 halves plus 6.3. That cancels out. And then you have 17 plus 6.3. That'd be 23.3. That's good. Okay, then we know that if this is 23.3 and this would have to be 23.3. So then we could just figure out what this last side is. So we could do 5 times 17 halves plus 2. That looks really fun. Let me grab my calculator. 5 times 17 halves plus 2. And that side is 44 and a half. Let me double check the other one. 14 times 17 halves minus 10.7. Sure enough, 23.3, so they match, so that means I did my algebra well. Okay, let's go on to the last example here. A steel mill produces roof supports by welding pieces of steel beams into an equilateral triangle. So as soon as I read that, I'm going to draw an equilateral triangle and label it. Each side of the triangle is 18 feet long. How many triangles can be formed from 420 feet of the steel beam? So you can kind of imagine that you have this long steel beam here that is 420 feet long, and I'm going to make triangles out of it. So I need to go all the way around this triangle. So if I do that, the perimeter of this triangle is 54 feet, and I want to know how many of these I can cut out of it, so I just need to divide. Okay, so 420 divided by 54, and we get 7.78. So now, be careful with the question, how many triangles can be formed? So 7.78 is not an appropriate answer because I can't form 0.78 of a triangle. So in this case, a word problem, I actually have to round down in this instance because I can only form 7 full triangles. So that's your answer there, is the 7. Okay, be careful with that. Even though this traditionally would round up to 8, I don't have enough to make 8 triangles. I only have enough to make 7. Okay, this was very short and very easy, but you can be assured that the problems we'll do in class will have a little spin to them, a little extra. So make sure you know your vocabulary forward and backward. See you tomorrow.